Problem number 23 is the following system. 2x minus 3y plus z is equal to -1. 4x minus 4y plus 4z is equal to -13. And 6x minus 5y plus 7z is equal to -25. Okay, so we're basically going to do the exact same thing as we did in the previous two examples. We're just going to start doing EROs, elementary row operations. And well, let's just get started. Everybody in the first column is even, so let's get a hustle on here. This is 2x minus 3y plus z is equal to -1. I am going to identify 2x as being my first pivot position, and now I want to use that to eliminate the other positions below it. So my first row operation is going to be twice equation 1 minus equation 2, and that'll be my new equation 2. And then my second row operation will be 3 times equation 1 minus equation 3, and that'll be my new equation 3. So let's do some of that arithmetic over here. Let's see. This will be twice equation 1 will be 4x minus 6y plus 2z is equal to -1. And then equation 2 is 4x minus 4y plus 4z equals -13. And we'll subtract.
Shouldn't the -1 be -2 because you multiplied by 2?
Yes, thank you very much. If you see something, say something. So watch out. Thank you very much. Good eyes. Okay. So we have 4x minus 4x, which is 0x. -6y minus a -4y is -6y plus 4y is -2y. And then 2z minus 4z is -2z. And -2 minus -13 is -2 plus 13, which is 11. And this becomes -2y minus 2z equals 11. For my second row operation down here, I'll do 3 times row 1, which will be 6x minus 9y plus 3z equals -3. And 6x minus 5y plus 7z is equal to -25. And we shall subtract. And this time we'll get 0x. -9y minus -5y is -9 plus 5, which is -4y. And 3 minus 7 is -4. And let's see here. -3 minus -25 is 22. So this will be -4. I don't know why I wrote y there a second time. This should be a z. Z. Minus 4z equals 22. And maybe you can spy with your little eye that now row 2 and row 3, or equation 2 and equation 3, are actually the same equation. They're just multiples of one another. So if we clean this up, a little, whoops, change back to black here. We clean this up a little bit. This is 2x minus 3y plus z equals -1. I'm going to do negative equation 2 as my new equation 2. So this is 2y plus 2z equals -11. And then if we do just a little bit of elimination here, I'm going to do -2 equation 2's plus equation 3. And that will be 4y plus 4z equals negative 22, and negative 4y minus 4z equals positive 22. And when I add those together, I get 0y plus 0z is equal to 0. And that's my last equation here. So we're done kind of early, but there's a lot more work to be done in this particular problem. So we're done with our row operations. I guess back here I should have annotated this with some color. I have my new pivot position, and now I'm trying to eliminate this position below it. And that's what we've done here. We've eliminated it. Okay, so what does this mean? Well, first of all, again, all variables have canceled out of equation 3, but the statement is true. 0 equals 0 for sure. So this means that there are infinitely many solutions. Since it has solutions, we say the system is consistent. Infinitely many solutions, but we're not done there. Because just because something has infinitely many solutions doesn't mean every ordered triple ever is a solution. So what we're going to do is we still need to back solve. Oops. We still need to back solve to find our answers. Just because there's infinitely many of them doesn't mean we're done here. So another way to treat this another way to interpret this bottom row, or equation 3, could also say 0z is equal to 0, which means that z is what we call a free variable. So z is free, or z is a free variable, meaning that it can take on any value we want it to take on. So z can be any value, but just because z can be any value, that does not mean x or y can be any value. So what are we going to do here? Well, we're going to use so I'm using some notation and terminology that you guys are going to see quite a bit in linear analysis when you guys sort of get to the end of your math career at Cuesta and blast through linear analysis for some of you. So you're going to see this in Calc 3 as well. We use what's called a parameter for the value of z. So we're going to let z equal t, where t is any real number, or we would just write t is an element of the reals. You guys remember that notation from way back when we started this class. So t is any real number, and so if that's the case, we now know what z is, and so we now back solve to find y in terms of t. So equation 2 says the following. If we look back up here in our last iteration of this system, this was our equation 2. 2y plus 2z equals negative 11. 2y plus 2z equals negative 11. But we're going to back solve where z is equal to t. So 2y plus 2 times t equals a negative 11. and we're going to solve for y. So this takes a little bit of getting used to, a little bit of practice here, but that means 2y is equal to negative 11 minus 2t, or y is equal to negative 11 halves minus t. So that's what y is worth in terms of t. And we have what z is worth in terms of t. And so we'll now back solve with y and z into equation 1. So equation 1 in our last iteration was this guy here. And so that's, 2x minus 3 times y, which is negative 11 over 2 minus t, plus z, which is also t, is equal to negative 1. And now we'll solve for x in terms of t. So this is 2x plus 33 over 2 plus 3t plus t equals negative 1, or 2x plus 33 over 2 plus 4t is equal to negative 1, or 2x is equal to negative 1 minus 33 over 2 minus 4t. So 2x is equal to negative 35 over 2 minus 4t, or x is equal to negative 35 over 4 minus 2t. And I feel like I made an arithmetic mistake in there somewhere. But that's okay. Oh, no, we're good. It looks good. Okay, so what does that mean for our answer? Well, it means that our ordered triple x, y, z is this monstrosity, negative 35 over 4 minus 2t, comma, the y value, negative 11 halves minus t and t. So this is a formula. So let's talk about what this is. This expression is a formula for generating solutions x, y, z to the system. What was our original system? Let's go back here and grab it. Which has infinitely many solutions. One solution for each value of t. So let's say we let t equal 1. Then, oops, let's shrink this a little bit so you can see it. If t equals 1, then x, y, z is equal to negative 35 over 4 minus 2, negative 11 over 2 minus 1, 1, which is the ordered triple. Let's see, that's 8 minus 8 more, negative 43 over 4, negative 13 over 2 comma 1 is one possible solution. You want another one? Let t equal, let's see, let's do negative 3. then x, y, z is equal to, or where was my formula at? Way back up here. If we have -3, we have negative 35 over 4 minus 2 times -3. Negative 11 over 2 minus -3, -3. That will simplify to be, let's see, that'll be a plus 6. 6 is 24 fourths. Negative 35 plus 24 is negative 11 fourths. Plus 3 is plus 6 over 2 is negative 5 halves. Negative 3 is another possible solution. And the list goes on as you choose more and more values of t. Probably the easiest one is let t equal 0. And if t equals 0, then x, y, z is going to equal, if we let t equals 0 in each case, we'll get negative 35 over 4, negative 11, and 0. So negative 35 over 4, negative 11, 0. Negative 11 halves, excuse me. And the list goes on. So there is an example of infinitely many solutions and how to back solve using a parameter.